Okay, hello everyone. Today we will be talking about what we learned in yesterday's extra learning study section. And yeah, okay, actually this one is from a long time ago, and yeah, it's kind of late, but I'm gonna do it anyway. So, oxidation number or oxidation state. Um, It denotes the charge of an atom of the element appeared to have in the combined state with the other atom according to the set of rules for formulated on the basis that electron pairs in a covalent bond belongs entirely to more electronegative elements. Rules for assigning oxidation states. Oxidation number of all atoms and of different elements in their elementary state in the free or combined state, or okay, this is quite a lot. And yeah, it's kind of different that each element they have different charges, and those are some combined rules. The oxidation mono equal to the charge of oxidation. And hydrogen, it's going to be +1 if with non-metal, and -1 with metal. Okay. Okay. For example, let's calculate CO2. So the overall charge is going to be 0. And O is going to be -2. The 2O we times 2. X is the charge of C. And we solve X equals to 4. Okay. That's how we get the charges. And okay, it kind of looks like organic chemistry. A mixture of this. Okay, just to clarify, sometimes the oxidation number is kind of a fraction. For example, this one is 0, the overall charge, and the oxygen is going to be -4, and then carbon must be +4, and you divide it by 3, that's going to be a fraction, but it's totally normal. And we need to talk about what is oxidation and reduction. Oxidation is gaining charge or a loss of electrons, or this is reduction in charges and the gaining of electrons. Oxidizing agents or oxidant is the one getting reduced, and the reducing agent is the one that's getting oxidized. It's kind of confusing. Okay, so for example, this one, sodium is the one that gains charge, and the chlorine is the one that losing charge and gain electrons. Because this 2 chlorine, it gains 2 electrons, and this 2 sodium, it loses 2 electrons. And chlorine is the one getting oxidized, and sodium is the one getting reduced. Yeah, there's just some more practice over here. Yeah, there's some kind of special question here. So, there's now some OH and H2O here. Okay, let me teach you how to balance those kind of equations. So you see there's some kind of oxygen element inside the equation, right? And you're gonna use the water and also the H element to balance the equation. If this is acidic solution, you're gonna have H plus. If this is basic solution, you're gonna have OH minus on the right side. Since this is acidic, you're gonna have H plus on the left side. Okay. So first you're gonna write the equation to figure out who is getting oxidized and who is getting reduced. And the fluorine, no, this is iron is getting oxidized, and manganese is the one that's getting reduced. So we're gonna determine the charge of each element first. So we all know that oxygen is always going to be -2, and Mn is going to be since this overall -1 charge, you plus 8 and you get 7. This one is just straight up plus 2. So the difference is going to be 5. That means manganese gains 5 electrons and lose 5 charges, and iron is the one that's getting oxidized. At the beginning we just write it iron lose 1 electron. However, we know that manganese gains 5 electrons, so then iron must be losing 5, and that's how we balance it, and we just multiply 5 by each. And now we're gonna check how many oxygens are there. And we get, okay, so we get 4 oxygens. So we have 4 different water here. See? And we're gonna take a look at the difference of the charges. Now we have 8 hydrogen over here, and we put 8 hydrogen atoms on the left.